This is a universal tester set up to generate tensile property data. Tensile properties are properties that are determined from data collected when a test specimen of a specified geometry is deformed in a uniaxial direction at a constant speed, and the resultant force and elongation recorded until rupture. The apparatus used to perform tensile testing is comprised of the following major components: a fixed head or stationary member carrying the grip, a movable crosshead or member carrying a second grip, and grips for holding the specimen between the fixed member and movable member. It also includes a force measurement indicator capable of showing the total tensile load carried by the test specimen during the test. An extension indicator, in this case a strain gauge extensometer, which attaches to the gauge area of the test specimen and records the distance between 2 points as the specimen stretches. Now we'll run a tensile test and generate some data. From the load extension data, we can create a stress-strain curve, which we see here. From this, we can determine the following. Tensile stress. Tensile stress is the tensile load per unit area of minimal original cross-section within the gauge boundaries, carried by the test specimen at any given moment. Tensile strength is the maximum tensile stress sustained by the specimen during a tensile test. When the maximum stress occurs at the yield point, it shall be designated tensile strength at yield. When tensile strength occurs at the break, it is typically identified as tensile strength at break. The yield point is defined as the first point on a stress-strain curve at which an increase in strain occurs without a corresponding increase in stress, and is referred to as a zero-slope yield. The elastic region is the region on a stress-strain curve where a material does not sustain any permanent strain upon complete release of the stress. That is, there is recoverable deformation. The plastic region is the region on the stress-strain curve where permanent strain remains after the release of the stress. In other words, non-recoverable deformation. Elastic modulus is an indication of the stiffness of a material and is typically calculated as the slope of a line drawn tangent to the initial straight line portion of the stress-strain curve.